Okay, so we know if we want to find the vertex of a parabola that's written in standard form, the standard form of the parabola is ax squared plus bx plus c. There's other forms of the parabola that describes the vertex in a different manner, and there's still other forms that, similar to the lines, these different forms of the parabola try to answer different questions. So we know, remember that the vertex of a parabola is simply the highest or lowest point. So lowest here and highest here. But we all know also that's where the maxes, that's where the min and the maxes are, and that is also where you have what's called the axis of symmetry that cuts the parabola evenly in half. Okay, so finally, the split of the graph is known as the axis of symmetry. So let's look at one. Remember, when we're trying to find the axis of symmetry, we don't have to first use the vertex formula, negative b divided by 2a, and take that information and plug it back into here to find your y value. All you need to do is use the formula negative b divided by 2a to find the axis of symmetry, and you'll have that special equation x equals something. Remember, the special equation x equals some constant is going to be a vertical line. The special equation of a y equals some constant will be a horizontal line. Okay, so we have the graph x squared plus 6x plus 9. So we identify who A is 1. We identify who B is 6. And so we plug it in our formula, x equals negative b divided by 2a. So negative 6 divided by 2 is going to give us 3. And so the axis of symmetry is going to be at 3. These values and these values are going to be equivalent. The y values in this case are going to stay the same, but the x values on this side are going to be a negative. Okay, so here we have another one, x squared plus 2x plus 1. We know to find the axis of symmetry, we use x equals negative b divided by 2a. We want to identify who a is and b is. And by looking up here, we see a is a 1, b is a 2. So we plug that into our formula, x equals negative b divided by 2 times, and that's supposed to be a 1. We'll get negative 1. So we basically have negative 2 over 2, negative 1. So the axis of symmetry is at negative 1. Now again, we didn't need to take this information here and plug it back into here, because we're just looking for the axis of symmetry. We know that's the line that splits the graph in half. So we have x squared plus 11x plus 24. Okay, so first we identify who a is. In this case, a is 1. Then we want to identify who b is. In this case, b is 11. Okay, so to find the axis of symmetry, we need to plug our values in. So we have negative Okay, so b is 11, so here it's going to be negative 11 divided by 2 times a. And remember, a is 1. Note here, I should have moved this a little farther over here. So that's why that numerator is kind of awkward. So we have negative 11 divided by 2 times 1. So we have a negative 11 halves. So the axis of symmetry is at a negative 11 halves. And so that would be, if we turn it into a mixed fraction, that would be 5 and 1/2. So over here, this is also the this negative 25 over 4. If I were to plug this back in to want the vertex, if I were to plug this back in, negative 11 halves, into here, my y value would be negative 25 over 4. So that's going to be 6 1/4, so negative 6 1/4. So it goes down, it goes out negative 5 1/2, and then down negative 6/4. But at the end of the day, the axis of symmetry is at x equals negative 11 half. Now remember, this point here, we can also say is the vertex would be negative 11 half and negative 25 over 4. And that would be the minimum. If somebody would ask, what is the minimum of this parabola, it would be negative 11 halves, comma, negative 25 over 4. Okay, so I just want to read this. This is kind of a different perspective on it. The graph of the quadratic function is a parabola. The axis of the symmetry of the parabola is a vertical line that divides the parabola half into 2 equal halves. The axis of symmetry always passes through the vertex of the parabola. So here's your vertex right here, the point. But then you have your axis of symmetry that goes through that point. The x-coordinate of the vertex is the equation of the axis of symmetry of the parabola. So just the x-coordinate. And we know that if I have x equals some constant, it's going to be a vertical line. So here, if we look at this, we have 2, 1. So we can plug, okay, I already got that off there, sorry. So is this the same thing? Yeah. Okay, so for example 2, find the axis of symmetry of the graph x squared minus 6x plus 5. Here they found c, but for our cases that's not necessary. They want to know what c is because eventually I'm sure they want to find the vertex. So for what we're doing, all you need is a and b. So we have negative 6 divided by 2 times 1, which simplifies to 3. So the axis of symmetry is the line 3. Now negative 3 this right here, 3 negative 4 is also going to be where the vertex is, and in this case where the minimum is. Okay, so in summary, if you got the quadratic in the form of ax squared plus bx plus c, you can use the axis of symmetry formula, which is negative b divided by 2 times a. To use this formula, you identify a and you identify b. You plug those values in, and the solution that you get for x is the axis of symmetry. So remember, at that point, if I took the value if I took this value here, whatever I got for x, and I plugged it back in, I would have a y value. And at that point, you have the vertex and the minimum.